Okay, so is a weight loss program based on exercise just as effective as a program based on diet? The 44 overweight people put on a strict 1-year exercise program lost an average of 26 pounds with a standard deviation of 8 pounds. The 56 overweight people put on a strict 1-year diet lost an average of 31 pounds with a standard deviation of 8. What can be concluded at the alpha 0.10 level of significance? Okay. So what is going on with this question? We're trying to compare which one's better, exercise or diet for weight loss is what we're basically testing here. So, and we're trying to compare them. We're trying to figure this out. So, how are we going to do it?
Is it going to be
what
a
are we
t-test?
going to do here? Let's take a look. It's probably be helpful to go to the notes. So I'm going to go to the notes. And you'll have these with you during the exam 4 notes. There they are. All right. So a lot of the battle, a lot of what's hard to get used to and to do on our exams now is identification, because there's so many different tests we have now. We've learned so many different statistical tests. It's kind of hard to tell which one we should use at different times. So how are we gonna do this? What's going on? Which of these tests? Let's go back to the question. Let me see. What are we comparing here? First off, are we comparing means or proportions, percentages? Is it averages, which is means, right? Or is it percentages, what we call proportions? Which one are we talking about here? Averages or percentages?
Averages.
Yeah, you see the word right here, average, huh? And then somewhere else too. Yeah, so, and there it is again. So again, we see the word average twice, and we don't see the word percentage anywhere. We don't see any percentages anywhere. So this is an average problem, huh? So we come back, we go, okay, it's average. So it's not proportions. Here, let me copy this for us. Exam 4 notes, I can write on it for us. Yeah. There we go. Okay, so it's not proportions, is it? There's no proportions. Okay, so it's means and mean. Now these are both means or averages, 2 and 3 from the notes. How do we know which one? Is it 2 independent means? Or is it the other one? Is it 2 dependent matched pair means? Well, do we see them in matched pairs? Is the data matched in pairs, like actor, actress, couple, male, female, subject before and after? Is that what we have? Do we have that on this problem? No, we don't have anything like that. What would that look like? Well, let me show you. Look at, here's the next problem. Look at this problem. See how they're matched? Well, maybe they're matched up, but see, they could be matched up on this problem. Or the next problem, let me look at it. Oh, look at this one. Younger, older, younger, older. See how they're matched up? So these are some other examples in which data is matched up in pairs. That's not what we have going on in this problem, is it? Everybody with me on that? There's none of that here on number 4. All we have is, an average and a standard deviation. An average in a standard deviation. We don't have matched pairs, right? There's nothing like that. So no, it's not matched pairs. It's not proportions. It's not matched pairs. It must be this. Two independent means. That means two completely separate averages. Remember, a mean is an average. Two independent, separate averages. Is that what they have here? Yeah. We just have the people that did the exercise program and the average weight they lost and their standard deviation. And the other group, the 56 people who did the diet thing and the average amount of weight they lost, average 31 pounds they lost. So we just have two totally separate, independent averages, means, don't we? For the two different programs. So that's it, two independent means. The two groups are not matched in pairs, they are independent, right? What do? We use the two sample t-test or the two sample t-interval. If you're doing a confidence interval, we're doing a test, a hypothesis test, I think, aren't we? Yeah, test, a bunch of test stuff. Yeah, so we're going to use two sample t-test, and our hypothesis is going to be that mu1 equals mu2, and that's the null, and the alternative is going to be greater, less, or not equal between mu1 and mu2. All right, two sample t. Here we go. So two sample t, or I think the way that it puts it is a t-test for the difference in two independent population means. All right, that's the option. Let's go on down. So this is going to be mu1 equals mu2. They tell us that right in the notes, right? I'm just looking right here in the notes. Mu1 equals mu2 and h1 greater, less, or not equal between mu1 and mu2. Okay. mu1, mu2. Now, which one is it for h1? Is it greater, less, or not equal between mu1 and mu2 here?
Not equal?
Yeah, how do you know? How are you picking up on that? It's a good job.
Just as effective means equal to, so it would have to be the opposite of that.
Yeah, good job, Natalia. Yeah, is everybody able to do it? That's a lot of the trick sometimes, huh? Yeah, we just look for the word, like, do they say greater, less, more, fewer, or do they say different or same, then it's equal, not equal? Yeah, you're right on the money. I'm looking for those words. I can't even find them. Where are they? I'm still read weight loss, 44. Oh, yeah, right here. I just flew by it. Yeah, right there. Yeah, good eye. You caught it. Thank you, Natalia. Just as effective. Yeah. Is a weight loss program based on exercise just as effective as the one on diet? Just as effective, meaning is it equal, right? Now they could have said, is the exercise more effective? If they had said more effective, then we would expect it to be to do. In fact, you know what? Actually, can I? Well, yeah, we better stick with their actual question. Now, you might have more effective. Let me give you some help here. Your version might say more effective. It might say more effective. And notice the first group, mu1, is the exercise group, and mu2 is the diet group. That's just the order in which they gave them to us in the problem. So mu1 is the exercise group. How do we know? Because that's just the group that comes first, the 44 overweight people on the exercise program. And then the second group was the 56 put on the diet, right? So mu1 is the exercise, mu2 is the diet. Now, what if they said more? What if they said, let me help you. Now, ours is just as effective, which means equals. So this will be equal, and the opposite of equals is not equal. That's right. But let me help you in case you've got a different one, because this can be specifically tricky. What if they said the exercise program is more effective? In fact, let me just put it up here where we can see it. What if they said the exercise program is more effective than the diet.
It would be greater than.
That version. It just randomizes it. It's different for each of us. So, and on the actual exam, of course, you could get something like that. So what would we do with that? If we did that, remember, this is mu1 and this is mu2, right? Exercise is mu1 and mu2 is diet. That's just the order in which they came in the words.
So it would be greater than?
Yeah, normally more means greater, doesn't it? But this one has a trick. Think about it with me. We're talking about weight loss, right? Oh, no, that'd be right, wouldn't it? Oh, yeah, no, never mind. I'm tricking myself. You're right. I thought it would be, I'm getting totally confused because I'm thinking, if something's more effective, your weight goes lower, but we're not talking about your weight. We're talking about how much you lost. Yeah, so you're right. It would just be greater. And if they said the exercise program is less effective, you're right. It'd just be like that. Than the diet, then that would be mu1 is less than mu2. Yeah, so it'd be just like we would expect. Okay, there's no trick. I was thinking wrong. Yeah, so more would be greater, less would be less. You got it. But they said just as effective, so that's equal versus not equal. We don't have more, we don't have, at least I don't. You might have more or less, so then you would do that. Right, all right, on the go. I'll quit fooling around here. So let's go to our calculator. What are we going to do on our calculator? We already decided 2 sample t-test, huh? 2 sample t, that's what it says down here in the notes. 2 sample t-test, and then you just put in the information to your calculator. I'll do it too. You guys are pros at all these tests now. And then you choose stats. Oops. You're going to choose stats because we don't have data, right? There's no data here. We don't have a list of numbers. We just have the summary statistics, right? They're just telling us, hey, the 44 overweight people, their average was 26. They're not showing us the 44 numbers, right? We don't have the data. We just have the statistics that summarize the data. So we choose stat, hit enter, and then they give us the numbers. They're going to go, in fact, I don't even hardly have room. They have so many numbers. I'll put them over here. So x1 bar, s sub x1, n1, and then they have x2 bar, s sub x2, and n2. And so we put those numbers in. Those come right out of the words. So average of 26 pounds, that's the first average. Standard deviation 8, and that's 44 people. That's N. Remember, N is always the number of people, you know that. X2, what's average? 31 pounds. 8, standard deviation is 8, and that's 56 people. 56 overweight people. There we go. Let's put that data in there. Do it too. And then we have to do whatever we had in H1. Mine is not equals. You might have greater or less. It's just whatever you had right here in H1. You know that. And then pooled is always no. We're not pooling the two groups together to find the standard deviation. We just always choose no for that and then calculate. So that should do it for us. And I'm getting a test statistic, a T, which we never do anything with. Funny why we even bother to report it. But anyway, it's kind of a hangover. It's something that used to be done from the past, a different way. When I taught statistics 20 years ago, believe it or not, I first taught statistics about 20 years ago. Is that true? Might be exaggerating. 14. Yeah, no, it's about 20 years ago. Anyway, we had to do all these things by hand with no calculator. So yeah, I think it was about 21 years ago when I first taught statistics. And we did them all by hand. So we needed those t values at that time. So the p-value is 4 decimal places. So that's 0.0025 to 4 decimal places. That's what I'm getting. And then the big question of the hour is always, is the p-value greater or less than the alpha level? So let's figure that out. We get the p-value point, oops, 0.0025. How does that compare to the alpha level? The alpha level is, what did they say right here? Alpha level is 0.10, at least mine is. And so that p is less, isn't it? That p is way less. And so you remember the saying, the most important saying we have in the class. If the p is low, are we good? We getting good with this? If the p is low, HO must go away, right? If the p is low, the null must go away. Is RP low? It sure is. RP is less. So HO must go away, which means we reject the HO. It goes away. So we come on up here. We reject. Remember, this is always weak evidence, and it's the assumption. You assume HO is true, and if evidence is weak, you keep that assumption. But we are rejecting that. We're going with H1 because evidence is strong. Strong evidence. So we are rejecting HO, and we're keeping H1. Evidence is strong, and what do we conclude? Mu1 does not equal mu2. So they're not equal. The diet and exercise are not having the same rules. There's strong evidence. Evidence that has only a 0.0025 chance of luck. That's what the p-value is. The chance the evidence was just lucky, right? That we just happened to get a lucky group of 44 people who did the exercise thing and the 56 people who did the diet thing. And it just, which group did better? On mine, it looks like the exercise people, no. The diet people lost more weight. The diet people lost 31 pounds. So it seems like diet is more effective than exercise. And could it have just been a lucky group of people? Well, not very likely. There's only a 0.0025 chance it's like, why? Because we have so many people. We didn't just do 5 or 10 people. We did 44 people in one group, 56 in another. That makes it a very low chance that all those people were just lucky. It's only an 0.0025. We don't believe it's luck. Very low chance of luck. Below our significance level, we wanted the test to have less than a 10% chance of luck. It does. All right, so what is our conclusion? Statistically insignificant? No, we have strong evidence. We have significant, right? It means a lot. It's enough. We have enough. Significant means enough. We have significant evidence, enough evidence, strong evidence. So cross off these insignificant ones. No way. All right, come on down here. Then what is it? Statistically significant? Yep. Statistically significant? Yep. So which of those is right? So there is sufficient evidence to conclude that the population mean weight loss on the exercise program is different than diet. Yes, that's it. Different, right? Not equal. Not equal means different. Things are not equal. They are different. That's right. That's our conclusion right there. H1, not equal. What does this one say? Oh, insufficient. No, we've already got rid of that. So there we go. There's our conclusion.